Hey everyone, welcome to homework. It totally stinks to have to do notes at home, I know. However, this is the only way we'll get through the whole year on time, and I'm trying to pace the year out better than I did last semester because we had to have this type of homework every single night last semester, and I'm not trying to do that to you this one. So we're starting logic and proofs, and it's a tough unit, but it starts out easy, right? We kind of just guide our way in. If you're interested in watching the video, this unit goes along with Geometry Nation Unit 1.3. Okay, and so the first thing starts out with inductive reasoning. And inductive reasoning is reasoning where you're making a conclusion based on observations and patterns. So I'll go ahead and write that down. Okay, and so I know that you have heard of deductive reasoning before. I went and pulled up the definition for inductive versus deductive reasoning on Google. So if we can pull that up, is it going to work? Oh, here. The main difference between inductive and deductive reasoning is that inductive reasoning aims at developing a theory, while deductive reasoning aims at testing a theory. So inductive is reasoning where you make observations and then come up with your own theory, and deductive is where you get a theory, have a theory, and then you prove it. Okay, so we are doing inductive reasoning now. We're making a conclusion based on what we find. Okay, so another vocabulary word that you need to know is conjecture. So conjecture is the concluding statement reached when you're using inductive reasoning. I was going to put doing, but I'll say while using inductive reasoning. Okay, so find the next 5 terms of the sequence, then write your conjecture. Okay, so it looks like we have 38 to 31 to 24 to 17. So hopefully you can see from 38 to 31, we're subtracting 7, right? Minus 7, 31 to 24, subtract 7. So you get to test this theory, make sure it works, right? And then go ahead and write the next 5 terms of the sequence. So 17 minus 7, 10 minus 7, 3 minus 7, negative 4 minus 7, and negative 11 minus 7. So the conclusion, the conjecture is the concluding statement. So how did we get there? To generate the next term, subtract 7 from the previous term. Okay. Number 3. 1, 4, 9, 16. 1 to 4, 4 to 9, 3, 5, 7, 9. So 25. Okay. Then 11 is 36. Oh, you know what these are? These are perfect squares. 1, 4, 9, 16, 25, 36, 49. Huh. Okay. And then 64 and 81. Okay, so I'm going to say each term is a perfect square. To find the nth term, square n. That's what I'll do. To find the nth term, square n. Okay, how about number 6? 7:30, 7:55, 8:20. Are they adding 25 minutes each time? Looks like it. So 8:20 plus 25 minutes would be 8:45. 15, so that's 9:10. Plus 25 minutes would be 9:35. And 10 o'clock, 10:25. Okay, so this is to generate the next term, add 25 minutes to the previous term. Okay, so I left you 2, 4, and 6 to find. I'll give you a hint for number 6 because this one's a little confusing. All right, so that was a pi symbol. So what is a counterexample? A counterexample is an example that shows a conjecture is false. Okay, so 7 through 16 says determine whether the conjecture is true or false. If it's false, write a counterexample. So the sum of any two consecutive integers is always odd. Okay, well, what is a consecutive integer? A consecutive integer is 1 and 2, 3 and 5, 3 and 4, right? Numbers right after the other. So 8 and 9, 10 and 11, 12 and 13. Can you guys think of any example where the sum of two consecutive integers would not be odd? Well, if you're adding an odd and an even, right? Because that's what we're doing here. The sum will always be odd. So this one's true. Okay, number 9. The product of two perfect squares is always a perfect square. Okay, well, let's try it. Perfect squares. So that would be 2 squared is 4, 3 squared is 9, 4 times 9 is 36. Okay, let's try another one, just a random one. Let's do 10 squared is 100. Let's do an easy one. Let's do 4 squared. So that's 160. Okay, so the product of two squares, two perfect squares, is always a perfect square. Oh, 1600. I forgot my 2 zeros. Okay, so the square root of 1600, square root of 1600 is 400, right? 40. 40 times 40. There we go. Okay, so I think this one's true. Charlie, shh. That's enough. Okay. Number 11. Dividing by 2 always results in a number less than the original number. Okay, so what if it's 8 divided by 2? 8 divided by 2 is 4. So that would work, but what if it's negative 8 divided by 2? That's negative 4. Charlie, do you have to bark during my video? Okay, so this one's false. Okay, and here's my counter example. Negative 8 divided by 2 is negative 4. Okay, number 13. If A times B equals 0, then A equals 0 or B equals 0. Yes, that's true. Right, if we're multiplying and the product is 0, one of the factors has to be 0. Okay, 15. All state names have at least 2 syllables. Oh gosh. Oh, Maine. False. Maine is 1 syllable. Okay, so I would like you guys to do all the even problems that I skipped, and I'll call on you in class. And then also come up with your own conjecture. So one of these, right, you're going to make a statement and then say whether or not it's true or false. And then I'll just call on a couple people to share theirs tomorrow. You only have to do one. All right. I hope you enjoyed this lesson, and I hope it wasn't too hard. I will see you tomorrow. Bye.